Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and it's our second video on working out the volume of prisms. I want to start by asking you to think back on what a prism is and how on earth do you go about working out its volume. Well, a prism was a three-dimensional shape whose two end faces were identical polygons. It had the same cross-section along its depth. Here are some examples, and to work out the volume, hopefully you'll remember, you just simply work out the area of the front face and multiply it by the depth of the shape. That's what we're going to do throughout this video with just various different cases of prisms. Here's the first one. Pause the video and have a go. Okay, let's work out the volume. The volume here, we're going to work out the area of the front face. Now the front face is a parallelogram. And you should remember that the area of a parallelogram is the base multiplied by the perpendicular height. So the base here is 9, the perpendicular height is 5, that means at right angles to the base. You ignore this 6. So to get the area of the face, it's 9 multiplied by 5, we multiply it by the depth, which is going to be equal to 10. So the volume is 9 multiplied by 5 multiplied by 10. 9 multiplied by 5 is 45, multiplied by 10 is 450. The units of length are millimeters, so the units of volume are millimeters cubed, and we're done. Okay, next question. Pause the video, have a go. So here we're asked to calculate the volume of this prism. It's a triangular prism, so we're going to need to work out the area of the cross-sectional face and multiply it by the depth back of the prism. Just to remind you that the area of a triangle is always a half the base multiplied by the perpendicular height. In this case we've got a base length of 8 meters, and because this is a right angle triangle, this 6 is perpendicular to the base, so that's going to be our perpendicular height. So we've got everything we need to work out the area of the face, and also we know the depth back of the shape is 20. The 10 meters here is a red herring, it is not needed in this question. So let's go and work out the volume. The volume, remember, is the area of the cross-sectional face, which we said is a half, multiplied by the base, which is 8, multiplied by the perpendicular height, which is 6, multiplied now by the depth back of the shape. Now let's try and work this out in our head a clever way. I would always do a half multiplied by the 21st, because that's 10, a nice easy number. Then I would do 10 multiplied by 8, let's say, would be 80, and 80 multiplied by 6 would be equal to 480. So the answer here is going to be 480, and the unit is going to be meters cubed, and we're done. Okay, next question. Pause the video, have a go. Again, we've got the front end as a triangle. We know that the area of a triangle is equal to a half the base multiplied by the perpendicular height. The base here is 44. The perpendicular height is this 15 at right angles to the base. This here is a red herring. Ignore this slanted distance, as is this. They're both red herrings. The depth of the prism is going to be 30. So if we're working out the volume of this prism, it's the area of the triangle, which is a half, multiplied by the base, which is 44, multiplied by the perpendicular height, which is 15, and all of that multiplied by the depth of the shape, which is equal to 30. You can get your calculator out and do 0.5 multiplied by 44 multiplied by 15, and then multiply that by 30, and you get yourself that is 9,900. All the lengths were centimeters, so the volume is going to be centimeters cubed, and we're done. Okay, next question. Pause the video, have a go. Here again we're asked the volume of this prism. Now the cross section is actually a trapezium, so we're going to need to remember how to work out the area of a trapezium. If we can get the area of the front face, we're going to multiply it by the depth of the shape, which in this case is this 80 here. So can you remember the area of a trapezium? Well, the area of a trapezium is always a half. Now it's the sum of the two parallel sides, which I'm going to write as a plus b, multiplied by the distance those parallel sides are apart. So in this particular case here, this side and this side are the parallel ones. So I can call this a, let's say. This length here, because that's 6, this also must be 6. So our b is 6 centimeters. The distance they are apart, the perpendicular distance, we call h, and that must be the 20. So in this particular case, the slanted distance of 29 is a red herring, and this 52 here is a red herring. It's not actually needed. So let's work out the area of this trapezium here. It's going to be a half, and we're going to add together 75, add 6, and we're going to multiply it by the distance apart, which is equal to 20, like that. Now I can do this in my head because a half multiplied by 20 gives me 10. 75 add 6 gives me 81. So what I'm working out here, that's 81. Half multiplied by 20 is 10, so I've got 10 multiplied by 81, which is going to equal 810 centimeters squared for the front face. So the volume therefore is the area of this front face, 810, and we're going to multiply that by 80. The volume as 64,800 centimeters cubed, and we're done. Okay, next question. Pause the video, have a go. So let's work out the area of the front end here. What we're going to do with something like this is split it into two shapes here. Call that above is a triangle shape 1, that there is a rectangle 2. So let's work out the area of 1. We know this entire length here is 18, and this part is 10. So 18 subtract this 10 must tell me that this height here, this bit between here and here, is going to be 8 centimeters. So the area of a triangle is always, it's a half the base multiplied by the perpendicular height. So it's going to be a half multiplied by the base. That distance is the same as that distance, so it's going to be 14, multiplied by the perpendicular height, which is going to be 8. A half of 14 is 7. 7 multiplied by 8 is going to be 56 unit centimeters squared. Let's work out the area of 2. That's simply a rectangle. The area is going to be the base, which is 14, multiplied by the perpendicular height, which is 10. So that's going to equal 140 centimeters squared. So the total area is the 56, add the 100 and 40, which is going to be 196 centimeters squared. So the volume of our prism then, we have worked out the area of the front face, this entire shape here, is going to be 196, multiplied by the depth of the shape, which is going to be equal to 12. Calculator out, 196 multiplied by 12 is 2,352. All the lengths were centimeters, the volume is going to be centimeters cubed, and we're done. Next one, pause the video, have a go. So we're going to work out the volume of this prism. Step 1 is to work out the area of the L shape at the front. Why don't we split this shape into two parts? Why don't we split it down there? So we've got ourselves one rectangle here and another rectangle here. Let's work out the area of rectangle 1. If that's 2, that's 2. The base is 2, or that's 2, you can think of it. 2 multiplied by 9. It's as simple as that. So the area of 1 is going to equal 2 multiplied by 9, which equals 18 centimeters squared. Let's work out the area of rectangle 2. Well, if that's 2 here, hopefully you can see if that whole distance is 5, this makes this 3 centimeters. It's got to be. Given that height is 2, that height there must also be 2 centimeters. So the area for that little rectangle left over, it's 3 multiplied by 2. 3 multiplied by 2 gives us 6 centimeters squared. So the total area is going to be the 18, add the 6, is 24 centimeters squared. Now we can go on and do the volume. We know the volume is the area of the front face, which now we've worked out as 24, multiplied by the depth of the shape, which is going to be multiplied by 6. And 24 multiplied by 6 is 144. So it's going to be 144, and the unit will be centimeters cubed, and we're done. Okay, last question. Pause the video, have a go. Right, just because this is a little more complicated, I'm going to draw the front face down here. And I'm going to mark in the lengths. That's 6 centimeters between here and here. This here is 5 centimeters. And this distance here is 3 centimeters, as this is 3 centimeters, and this here is 2 centimeters. Okay? Right. To work out this shaded area, rather than break that up into lots of different rectangles, hopefully you could see that it's going to be the area of the whole rectangle. Take away this little bit here. Take away this little shaded bit here. So the whole rectangle is 5 multiplied by 6, which is 30. Take away this little rectangle here, which is 3 wide by 2 high. So 5 multiplied by 6, like I said, is 30. Take away 3 multiplied by 2 is 6. 30 take away 6 is 24, and the unit will be centimeters squared. So the area of the front face is 24. So we're going to do the volume is therefore the area of the front face 24 multiplied by the depth into the page, which is 10. And when I do that, I get 240, and the unit is centimeters cubed, and we're done. And that's it for this video. Thanks loads for watching.